We're dancing. All right, so I'm going to go here real quick. Go to our page. Let's see. Oh, look. We're in week 5 now, right? Okay. So, oops. Got it. I don't need this. So, we're missing Tuesday or Wednesday's video because we did a test. So I'll put another video here. I'll put the homework here too. Okay? And the notes and stuff. And then I'll also go into next week, which will be some of those pages in there. So, let's talk about what we're doing. Go ahead and close down. All right, so we're starting brand new unit. This is in second semester's workbook. And I think y'all are going to be like kind of going, okay, this is a breath of fresh air. We are stepping away from graphing. Word problems. Well, there's 3 things here, and I don't think there's one word problem in here. There are letters called variables, but we're doing that. So, ready to play? We're good to go? All right, so we're going to start combining like terms. So the very first problem I have in our notes, we have 3x squared plus 2x plus 5 plus 7x squared plus 5x minus 3. I believe that's the very first problem on our page. Yes? Okay, so we're going to take a look at it. Item 1, we have 2 different items that have parentheses around them. Parentheses usually mean, hey, we could distribute something over the parentheses. So would everyone feel comfortable that there would be a 1 out in front of here? Is that like, dude, where did that just come from? Is everyone comfortable that there would be a positive 1 in front of that one? So theoretically, I could distribute the 1 over, but if I multiply anything by 1, I get back itself, yes? Okay, so I'm going to be able to drop my parentheses. Because I'm dropping the parentheses means, theoretically, I did indeed distribute this over. Now, I don't necessarily have to do it. I don't have to say, okay, what's 1 times 3x squared? Because we know it's 3x squared. What is 1 times 2x? Well, we know it's 2x. What is 1 times 5? We know it's 5. And then I'm going to do the same thing here. Now notice I have a positive. So that's what's taking place. So I have plus 7x squared plus 5x minus 3. So now we want to start combining like terms together. And a like term is the same letter, and that letter has to be raised to the same exponent. So let's just do this. I have 3x squared and I have 7x squared. They're both x squared terms. Agreed? When adding or subtracting, I can combine those together. I just count them up. So basically what I do is I go 3 plus 7 is 10. X squared stays x squared. The exponent doesn't change when I add or subtract. Now when we multiply in a little bit, it will. But right now it doesn't change. Then I have 2 more like terms. So I have 2x and 5x. 2 added to 5 is 7x. And then I have 5 and negative 3. So 5 minus 3 is 2. Here's my answer, and I'm all done. Kind of a breath of fresh air. You're like, okay, I came in this morning with anxiety because I didn't do so well on that quiz. I'm a little mad at myself, but I feel a little bit better. Okay, let me go to the bottom of this page. Now, what's the difference between the top problem and the bottom problem other than the problem? Yes, sir?
You can't multiply everything by 1. You have to multiply the second one by -1.
I couldn't have said it better myself. Here, you get to teach this one. I'm just kidding. Just stay there. Great job, Maddox. All right, so I have 3x squared minus 2x plus 5 minus 4x squared minus 3x plus 6. Okay, Maddox, you nailed it. I couldn't have said it any different. Now, on the last problem, I said, hey, I have a 1 in front of here. So basically, I can distribute that over. So I get 3x squared minus 2x plus 5. Agree? That's exactly the same. But it was pointed out to us that we have a subtraction sign here. So theoretically, I have a negative 1 here. So if I distribute negative 1, if I multiply everything by a negative 1, the signs have to change. So I'm going to go negative 1 times positive 4x squared. That's going to give me negative 4x squared. Negative 1 times negative 3x is positive 3x. Negative 1 times positive 6 is negative 6. And I want to highlight this. Do you agree that all of those signs changed now? And it seems like a silly thing, but this is one of the #1 spots in algebra that students make mistakes. You multiply just fine, but you sometimes start ignoring, oh, I have a negative. Okay? Does everyone feel comfortable with what I've done? From here, I'm going to go ahead and combine like terms. 3x squared minus 4x squared. What's 3 minus 4? Negative 1. So I get negative 1x squared. Okay? Now, do I have to have a negative 1, or could I just have negative x squared? Yeah. Are you wrong if you put negative 1x squared? No. But mathematically, it's not always the most accepted. You know, like some people are like, why would you put that? It's always assumed. Well, don't assume it. If you feel comfortable putting it, put it. You're not offending me. Let's see. What else we got? Negative 2x added to 3. So 3 minus 2 is 1. And let's just keep the fashion going. 5 subtract 6. Negative 1. Here's my answer. No, you don't have to do it in different colors. But I'm just showing you when you add or subtract, like terms are the same letter and the same exponent. Okay? Am I going at an okay rate? Everyone still feeling okay? All right. All right. Oop, we got a find the perimeter problem. All right, so let's get fancy. Let's get myself a rectangle. All right, and I know that they told me that this is 3x plus 2, and this is 7x plus 5, and they want to know what the perimeter is. Now remember, the perimeter is one of those equations that kind of is you have to know. We've been working with it for a long time. You've been working with it for a long time, and all the way through elementary school. So let's just make sure we feel comfortable about this. Does everyone feel comfortable that this side over here is 7x plus 5 as well? Is there any disclaimer in math where you're like, I don't know? And if it takes place, do you feel comfortable saying that this down here is 3x plus 2? That all seems to make sense? So remember, the perimeter equation is 2L plus 2W. And we found out on the last test, it was shocking to some, oh my gosh, I have a width. Does anyone want this last swig of Gatorade? Here you go, Dan. So length and width don't have to be equal, or don't have to be, the length can be longer than the width, but the width can also be longer than the length. I'm sorry I shattered your dreams that 4th grade told you in math, but length doesn't always have to be the longest side. But, so we have to do the perimeter. Now let's pretend we don't even remember the perimeter equation. We can't remember it. But we know it's all the sides added up. Agree? So, yeah, we have the perimeter equation, and it's great. So, theoretically, we would want you to do this way. 2, 7x plus 5 plus 2, 3x plus 2. We could do that way. We could. And we'll save that for a second. But let me do this. Count with me. Hey, 3x and 7x are like terms, yes? So 3x plus 7x is 10x. 10x plus 3x is 13x. Plus another 7x is 20x. Agree? And then 2 plus 5 is 7. 7 plus 2 is 9. 9 plus 5 is 14. Oh, cool. I got the perimeter that way. I got the perimeter that way because, you know what, I totally forgot the perimeter equation. I know Mr. Stirp says that we have to remember it, but I just gave you an out. Now, let's do it the other way. Let's do it this way. I'm going to distribute 2 over the parentheses. Do you feel comfortable with that? 2 times 7x is 14x. 2 times 5 is 10. Yes? I'm going to distribute positive 2 over that. So I get that. Agree? I'm going to combine like terms. Is this the exact same answer as this? I just gave you 2 ways to do it. But things that you kind of have to remember. You have to remember that a rectangle has 2 sides that are equal and then 2 other sides that are equal. If you know that, you can go through this problem and not even worry about the perimeter equation. Which way do I want you to do it? Whichever way your mind is going to work. Deal? Feel comfortable? Can I go to the triangle below? Am I doing okay for you? Yeah. This is your first day. You're like, dude, this guy's great. Oh, a couple things you need to know about me. Item 1, if you ever have to use the restroom, never have to ask. Take care of yourself. You know your body best. Closest restroom from here is just go left out the door. It's down about 25 feet. So take care of that. I also have a bad sense of humor. If you trip and fall, I point and laugh. If I trip and fall, you point and laugh. Deal? Okay. Everything else you should be able to figure out from here on out. Can I move off this screen, my friends? Here we go. Ready? All right. I got to use the other triangle. Where's the triangle I want? I want the one that leans. What do you mean you're not going to show me? That's the one. So that kind of looks like the one that's on our paper. Yes? Whoops. I don't want to just do it and highlight. That's kind of not fun. So I know that this is x minus 4. I know this is 4x plus 6. And I know that this is x squared. And I want to find the perimeter, which means I'm going to add up all 3 of the sides. Okay, so the perimeter of this. Let's take a look. X squared. Are there any other x squareds up there? Nope, so I'm writing it down. Good so far? Okay. I have x plus 4x, which is 5x plus 5x. And I have negative 4 added to 6, which is 2. Problem's done. I have the perimeter. So adding and subtracting, the exponent won't change size, and you just count it up. Cool. I got 2 more slides left. Are we good? Am I teaching at okay level? Can I move to the next slide? All right, next one. I'm going to make another triangle. Got to find my fun shape. That's the one I want. I want that one. All right, now notice this one. Okay, my friends. So in order for that perimeter to have taken place, I would have had to have added up x plus 7 and 3x plus 2 and some unknown. What do you think?
What you can do is you combine the 2 like terms in your triangle to subtract the perimeter.
I think we got a new teacher here. Maddox, you impressed me. Thank you. Yeah, I think what was stated, and correct me if I'm wrong, Maddox said I could add these together. So that's going to give me 4x plus 9, agree? So this is unknown. So in some way, shape, or form, we're going to have to try and figure out what we'd have to add to this to get to that. So what I'm going to do is I'm just going to take this, and I'm going to subtract. Now notice I'm putting this in parentheses for a reason, because I need to subtract both terms. And if I have a parentheses with a negative in front of it, that's technically the same thing as a negative 1. So I need to distribute here. So I get 6x plus 10 minus 4x minus 9. Agree? This is not really part of the problem now. I just used it so I kind of wrote it off to the side. All right, so 6x subtract 4x. 6 minus 4 is 2x. 10 subtract 9, 1. What is this right here? What does that mean? What is that? What did I just find? That's my missing side. That's right here. And you could double check it. You could say, okay, if I go 2x plus x, that's 3x. 3x plus 3x is 6x. Check. 1 plus 7, 8. 8 plus 2, 10. Check. It worked. So this is a little bit of inductive reasoning because you have an answer, but you have a missing side. It's almost like we're playing Jeopardy. This is my last question. This is my last slide for today. Agree? Okay. So, my friends, I got to break out a rectangle. Let's go rectangle, this one. They tell me I have this being 2x plus 3, and we know we have a perimeter of this. Yeah? I think you're right, but why do you think you're right? I think you're right, though. It's a rectangle. And by definition of a rectangle, we've known this for a long time. Top and bottom have to be the same. Left side, right side have to be the same. I like it. So Dan stated this. If that's 2x plus 3, this has to be 2x plus 3. I'm pretty comfortable with that. Now I'm kind of stuck. I think Maddox has an idea. But hang on. Do you feel comfortable with what I've done so far? I'm trying to find those other two lengths. I know that bottom length. I got it. I'm done. I'm done with the bottom length. I know that that bottom length is 2x plus 3. I'm happy about it. But I know if I were to add this and this and this and this together, if I add those four colors together, I would get 20x plus 30. Maddox, what do you think? I know you're chomping at the bit on this one. You're seeing it. Okay, so let's add these together. I feel comfortable saying that's 4x plus 6. Do the rest of you feel comfortable with that? So let's do what Maddox said. So I'm going to take 20x plus 30, and I'm going to subtract 4x plus 6. What should I do with this right here? What should I do with this negative out front? Distribute it. Yeah. So I get 20x plus 30 minus 4x minus 6. 20x subtract 4x is 16x. 30 minus 6, 24. Okay, now, do we feel comfortable up to this point? Is there anything that's up there that we're not done, but I want to finish it? Why? I think that's great, but they're two equal sides. Divide by 2. Right. Yeah, because we added the top and the bottom. They were the same. We know that the green side and the blue side, or if I think they're green and blue. My colors are bad. Those two, the green and the blue side, have to be the exact same. They're exactly equal. We have two of them that are exactly equal. So Dan, I think this is what you said. If I divide this by 2 and divide this by 2, that should give me 8x plus 12. And if that means that this would be 8x plus 12, and this would be 8x plus 12. How did we know to do that? We had two sides that are exactly the same. I know that those two sides added together was what we wound up with. But hey, let's double check this. If we are right, that means if I add 2x to 2x, I get 4x. That's 16x. So 16x plus 4x is 20x. Oh, this is starting to look good. 3 plus 12 is 15. 3 plus 12 is 15. 15 plus 15 is? Do we feel pretty comfortable about how that problem worked out? Yes, sir.
Another way you could have done it also is you could have divided the original problem p equals the derivative of e by
Whoa. So you're saying go 20x plus 30, divide those by 2 to get 10x plus 15, and then just subtract the 2x plus 3? And does that work? I think it does. My friends, we just had multiple ways of thinking to go through this problem. And I'm going to tell you, this kind of problem right here, this might be something that would be probably like number 3 or number 4 on an ACT or SAT math section. Yeah. Now, there's certainly things written on the ACT or the SAT that you have not seen, but it'll work. It'll work, yeah. Let's think. Let's think for a second. I don't want to say it's always true, but let's see if we could put a reasoning that would always make to back you up. We have a perimeter of a rectangle given, and we have one side. That's the original. That right? So theoretically, could I take the perimeter always and divide by 2 and then just subtract it to get the other missing side? I think so. I think that's a great way of thinking. If you're not seeing it that way, then you can continue to do it the way that we had done it. And which way is the right way to do it? Well, they both got us the same answer. So which way is right? Both. Both. Huh. My friends, I feel pretty comfortable about this. And what I would actually like to do, let me just take a look. I just want to see what I got. So that we did those notes. My friends, I have enough time that I can teach the second lesson, and that takes the video off your plate to having to watch. Do you want to do that? It's the same concepts. That would take away from having to watch a video. So if you get to the side that says PEF3, says watch the video on Schoology, I could teach that now. You want to do that, or you want extra homework? It's like, let's see, extra homework, or we do it now? Everyone feel comfortable? Everyone feels comfortable with the first stuff we did, yes? Cool. So this is going to switch over to PEF3. And what I had planned is I was going to have you watch this video at home, but this might be better. Now, the last page of this will be what we do on the remote day on Monday, okay? All right, so let's take a look. So multiplication, distribute. Distribute is a form of multiplication. Okay, so there's a problem that, the first problem I gave you is 5x squared times 7x to the 4th. So now we're no longer adding and subtracting these. I'm going to multiply. So I'm going to multiply 5 times 7. I believe that's 35. Now watch this. I'm multiplying those x's together. Agree? X, and you're going to find out this analogy in a little bit, but I'm not going to share the whole joke with you. When multiplying, like bases, the exponents are like bunnies. You just count them up. Just count them up. So it means I'm going to go 2 plus 4, so I get x to the 6th. That problem's done. Because I'm multiplying, if I go add, subtract, I can't change the exponent. But when I multiply, we count them up. Again, exponents are like bunnies. You'll eventually get the rest of that joke. Not yet. All right, the other problem on that page is I have negative 6x to the third times 10x. Okay? So, my friends, do you feel comfortable that if I have x sitting there, that's actually x to the first? Cool. Negative 6 times 10 is negative 60. Add those together because we're multiplying. Problem's done. Seem okay? Can I get on to the next page? No, they were just two different problems. Two different problems. Yeah, just two different problems. The next page is two different problems as well. The first problem I'm going to do is this. 8x plus 2x squared plus 3x minus 6. Okay, this is distribute, yes? Now, the first thing I want to make sure we recognize, if we have x, that's x to the first, and that's x to the first. Is that okay for me to put that? All right, we're going to distribute. I could use a better color than that one. It's like I can't see it. That's like sunshine. I like that. All right, let's see. 16x to the third. Yes? 8 times 2, 16. X and x to the second, x to the first, x to the second. Add them up. Okay, and then I'm going to get 24. I get x to the first and x to the first, so that becomes 1 plus 1, which is 2. Agree? And then distribute the last. Negative 48x. I could put that to the first. I could put this. I'm just going to highlight that. I can put this if I want. I don't have to have it. It's not wrong if you put it. It's your choice. That's our answer. It's done. These, you're like, hey, can I just add these together? Well, yeah, if it was x to the third and another x to the third, but it's not. They're not like terms. Can I move forward? There's one more problem on that page, yes? X squared, 5x plus 7. Okay, we're okay to this to the first, yes? Yes, yes. All right. 5x to the third plus 7x to the second, or squared. You can say to the second or squared, doesn't matter. Done. Happily done. Okay. At the bottom of your sheet, they have this term that says double distribute. Sometimes we might call it FOIL. Now, there was a movement right around when y'all were born to create this new math. It's the exact same math we've always been doing, but you had these people that thought they were good going, we're going to do Common Core. Common Core doesn't like saying FOIL because FOIL is a trick. FOIL is first, outer, inner, last. That's all it means. So it's double distribute. Okay, we put a man on the moon by using the word FOIL. So I don't think our math was too bad. Okay? We learned how to put people in rocket ships and launch them into outer space by using the math. So the acronym FOIL is not like going to destroy you. I think if we put somebody in outer space, put somebody on the moon, launch space probes that have now left our solar system, by you doing this kind of math, I think we're okay. Common Core was just a sales pitch for a company to make money on the backs of students, to sell textbooks. Guess who doesn't use their textbooks? This school. Common Core came out. Paul Trollinger, who was the math coordinator at the time, looked right at the superintendent saying, hey, we're going to do this. And he goes, you are showing me zero evidence that this works. We're not doing it. That's why we started writing our own textbooks. Okay, we wrote those. We came up with those. We make them. We modify them each and every year, which is cool. It benefits you all. Some of these other schools that are doing other stuff, I feel kind of bad for them. All right, so let's take care of this problem. Both of those terms are called binomials. There's two terms, bicycle has two wheels, binomials, okay. We're going to distribute twice. So first thing, I'm going to put that 3x to the first, 7x to the first. Good so far? Ready? 3x times 7x, 21x squared. I feel happy. Yes? 3x times negative 3, negative 9x to the first. I don't have to have it to the first, but I can. It's not going to hurt anything. And then I have to make sure that I distribute 2 times 7x. And then distribute that. Now I think we have two like terms in there. Anyone want to take a shot at what the two like terms are? Maddox. What's one? Oh, I was meaning there's two separate things, but yeah, you're right. You're totally right. Yeah, that's going to be my like term. So we can go ahead and combine those. So 21x squared stays as is. 14 minus 9, I believe, is 5. So I get 5x. I could put it to the first. I'll just keep it as that. Minus 6. Problem's done. So you have to see that you have like terms. If you don't have like terms, you just leave it as is. We good so far? Can I move on? This is another double distribute problem. Agreed? So when I have x sitting there right now, I'm just going to put it x to the first, x to the first. That way we know how to count them up. And I'm going to go 2x squared times x to the first. I think I get 2x to the third. Would you agree with that math? 2x to the second times negative 4 is 2 times negative 4? Negative 8? Three x to the first times x to the first. Three x to the first times x to the first. 3x squared. 3x minus or times negative 4, negative 12x. Does there seem to be like terms in there? Yeah. It looks like these happen to be like terms, so I need to combine them. So 2x to the third stays as is. Negative 8, or negative 8 plus 3, negative 5x squared minus 12x. Problem's done. Good to go. We good in the hood? Can I move on? Second problem on the page, down one, right? Ooh. Okay, this one has a little bit more of a curveball for it. You get a sip of coffee for this one. Anyone else want to share a sip? Okay, so my friends, I'm going to actually move this down a smidge. That works. Hey, that was cool. All right. 3x to the first times x to the second. Three times 1 is x to the first times x to the second is x to the third. Good. Okay, 3x times 2x. So 3 times 2 is x to the first, and x to the first is x to the second. Cool. 3x times negative 5. 3 times negative 5. Negative 15 with an x along for the ride. Okay. Now just change color. 2 times x squared. 2x squared. Does that seem okay? 2 times 2x. To the first, thank you. 2 times negative 5. Negative 10. My friends, I believe we have some like terms. 3x squared, there's no like term with that. 3x to the third, we're done. But is this and this, are those like terms? They have the same exponent, same letter. 6 plus 2 is 8x squared, or 8x to the second. This is also a like term, and this is also a like term. Negative 15x plus 4. Negative 15 plus 4. So it costs $15. You have $4. How much you owe? 11. And this is its own term. Problem is done. Woo! Last problem. 5 minutes left to do it. I don't think it's going to take 5 minutes, though. So for the last 4 minutes, we're going to play hide and seek, okay? But you have to hide in the classroom. I'm just kidding. Can I move on? Last problem. I have 3x parentheses x plus 2 plus 5x parentheses 7x minus 3. All right. So I'm just going to take this 3x to the first. I'm going to multiply here. What's 3x times x? 3x squared. 3x times 2. 6x. Yay. We're done with that part of the problem. Now I need to make sure I'm going to distribute negative 5 over this. Negative 5 times, or negative 5, or 5x times 7x. 35x squared. Negative 5, or 5 times negative 3. 5x times negative 3. Negative 15x. Friends, does it appear there's like terms? Yeah, the 3x squared and the 35x squared, those are like terms. So if I add those together, I get 38x squared. Notice the exponent didn't change size. Like terms. Negative 9x. Friends, problem is done. Problem is done. All right, so my friends, I don't have this posted yet, but I'll get it posted in a little bit. What I'd like you to work on, this will be due on Monday during remote. Now, I'm going to warn you. I've noticed this is in the new workbook. So this is PEF number 2. And let's take care of the odds. And PEF number 3. And I'll show you where to find these. PEF number 3. We will also do the odds. Now, I will post these. If you don't have the workbook yet, that's fine. I'll post these on my Schoology page. Okay? So you can always just click on and look at the PDF. It's your choice to write them on a separate sheet of paper, print them off, or get the textbook. Yeah, buddy. Cool. Anyone else have a sign-up sheet for next year? Okay. If you haven't gotten it yet, it's nothing wrong. It's just they haven't gotten to you yet. So I'll sign it off. So does everyone know what to do? Hey, there is one last set of notes. PEF number 5. It says Monday lecture remote. So make sure you have this page. Now, something I noticed from the last chapter, and I think a lot of you did poorly on the last test, because some of you, hey, did you do your homework? Oh, I forgot. Can you please budget time to get these 2 pages done by Monday? Please. It's a trend that people are doing. Go, oh, sweet, I get full credit for it. Yeah, you get full credit for something that's worth a small percent of your semester grade. So if you're always behind and just copying down what I do and saying, oh, look what I did, great, but it's not going to help you. Some of you are not practicing, so please practice. Have a great day, everyone. Take care of one another. Do you know where to find all my stuff? You feel comfortable finding it?
Yeah.